Welcome back to the shrine. Today on the altar is a Dewalt made in USA drill. It's a DWD110 3/8 10mm VSR drill. I guess VSR is variable speed reversible, made in USA with global materials. Type 10, 120 volt AC, 50-60 Hertz, 8 amps. Corded. Not even sure if anybody is still using corded appliances in the workshop. I thought everything is cordless these days. It's a pretty big beefy cable. There's about 6 inches of it. 18 AWG. Whatever. Good cable. No grounding on it. You can see it's just 2 prongs. We got the wide and the narrow prong. So that's pretty much it. It's a little bit bent. Looks like copper. Looks like it's made out of 2 thin sheets of copper kind of sandwiched together to get the thickness. So the drill was handed to me by a friend, and he described it as it's got issues at high torque when you're using you know, like a large drill, a 10mm 3/8 maybe drill. I did some testing in 3/8 thick steel, and I had no issues drilling like a 5/16 hole. And then when I was using the 1/2 inch, this is what happened. Half an inch drill into 3/8 thick steel. There's a hole pre-drilled. You can see that if I push it hard, it will not start at all. And then sometimes it will stop. So the motor is turning. The chuck is holding the drill, so the chuck is not slipping. Something inside slips. So the drill is definitely slipping at high torque. So we're gonna go inside, take it apart, and see what's wrong with it. 7 fasteners, and the clamshell comes off like that. Look at that, it's clean. It's got these inserts here, these rubberized inserts, and looks like the bolts are all the same size. That never happens. They always use different sizes, so you need to figure out which one goes where when you're putting it back together. Look at that. The grease is in pretty good shape. Right here you can see the grease is sort of fresh. It's not even discolored over there. And then in this area you can see that there's some debris in it. There's a little level on this end, so when you're holding the drill you can kind of manipulate the bubble into that top spot, so that way you can make sure that the drill is vertical. The other question, if your workpiece is horizontal. Yeah, interesting, nice little bubble. Look at that. Think of a beauty. It also has this yellow hue. So the fluid in it has this yellow hue. So it matches the housing. And I've read somewhere that they have a date code on it. So these drills were issued a recall by Dewalt because of shock hazard. Some cables inside can shock you. So obviously the entire housing here is plastic. So you're holding on to a plastic housing. And when you are tightening the drill chuck, you might be holding on to this collar here, which is metallic. And then it is connected to the shaft, and that is connected to the motor. So we'll see. We'll check if it has a ground loop inside. So the date code on this one is 2018 08 FY. So 2018 is the year, and 08 is the that is the week. And I was reading about it online. So there was a recall for the part numbers from 2017 37 to 2018 22. So there's a recall on this particular one. And I think it's called a safety issue because of the internal wiring. And something about the internal wiring can come into contact with metal parts, and then that can shock you. So let's see if there is a loop here. Okay, so that is connected. So you can see that the user has access to this metal piece here. So okay, that is connected to the drill. So if you put a drill in here, a metallic drill, a steel one, then that is going to connect to that part. So this part connects to the shaft, but as you can see, it's not connecting to the bearing. It connects to the gear, so it connects to this large gear. Yeah, let me bring it closer. Okay, so this connects to the large gear, which connects to the small gear, which is connecting to the armature shaft. Okay, so this is the armature shaft, this is the armature bearing, here's the commutator. Okay, and then this is the lamination. So even if the internal wire is connecting to the lamination, one of these wires is touching the lamination, that's not supposed to be a problem. So it's not connected to the brush holders, it's not connected here to any of these components. I don't know. There was a recall. I don't see a reason why it was recalled. Because obviously you have power here on the commutator, and you also have power in the field coil. But all the body is plastic. So the user's holding this. The user's holding the plastic body. And the user might touch this collar here or the drill when it's energized. But when it's energized, it's rotating. So you must be, stupid enough to hold on to the drill when it's spinning. But I can imagine that, someone is tightening up the chuck by holding on to this collar and then operating the switch, and that would turn it on. So enough of that rumbling. So inside here we don't have much. We don't have much at all. So here's the business end. That's the chuck, and you can see that it's kind of loosey-goosey. It's not the best chuck I've seen. It says 10 millimeters or 3/8, which is not equivalent because 10 millimeters is 10 millimeters and 3/8 is 9.5 millimeters. But that's what the chuck says. I think it's just it probably can take a 10 millimeter and period. Release hand tight grip. It's got some name on this one. Jacobs. Wow, that's a Jacobs chuck. Wow. That's probably the worst ever Jacobs chuck I ever seen. Okay, so what we got here? I thought there's a clutch inside, but there's no clutch. So all we got here is just a direct drive. So you can see that motor has a small pinion, basically a gear, and then we have a large gear here, and it's helical. So we got a small bearing here, roller skate bearing 608Z. So this is a roller skate bearing, double shielded. And then on the business end we have a larger bearing which has a proper seal. I've read some people describing the chuck being torn, or something's wrong with the chuck, but look what I found. Huh? Can you see that? You can see that the teeth are chewed off of the gear, so that's why it's slipping. So when you start drilling and it gets to this location here, then it will just stop, and then the pinion is gonna grind here. So that's where that black powder or black grease here comes from. So you can see that as it's spinning, it's mixing this grease with the powder, and then it's spitting it here. So that's where that grease is coming from. I'm guessing that this part is available. This part is readily available, so you can buy this assembly online and basically replace this gear. I think this gear is press fit onto the shaft, but you know, this is a $60 hand drill, and I'm not sure how much this cost, and there's also shipping, so you can probably get this part for 25 bucks. If you have emotional attachment to your drill, then go for it. It's worth to do, but for this drill it's pretty much end of story. I believe this is a powder metal gear here, and as such, powder metal is basically just you know, as the name says, it's just metal powder. They compress it under high load, and then they just sinter the hell out of it. So it's a sintering process, and what happens is this doesn't behave like regular steel. So powder metal parts don't go through the traditional yielding process. So if you have like a piece of steel, so here's a pin, and you can see this is made out of steel. It's magnetic. So if I bend it, you can see it goes through yielding, and then once it goes through yielding, it will have a permanent deformation. So when you have a gear made out of steel and you apply a load, that gear teeth is going to bend, and if the load is higher than the yield strength of the material, it will create a permanent deformation on the part. Now, typically if you look at material properties, you can see you know, what the yield strength and what's the ultimate strength. So if you have a material where the yield strength is 200 MPa and the ultimate strength is 350, then you have a little reserve. Okay, so it will plastically deform before it fails. Now the powder metal on the other side, you can have, let's say, 540 yield and then a 560 ultimate tensile strength. So they are pretty close to each other. And so what happens is, because of that, the powder metal parts will behave like glass. Okay, so they will just abruptly fail. And I think that's what happened here. I also believe that's why they use the helical gears in this case, because that helps the design to distribute the load better. Also, the fluctuation of the load when the gears are meshing is going to be less. And then most importantly, you know, the contact ratio between the small and the big gear is going to be larger. So you can see that this pinion here only has a couple teeth. So here, trying to count the number of teeth, I think it's either 4 or 5. It's hard to do with this. Yeah. Okay. So it's 4 teeth. This gear has 4 teeth, and this is the bearing on the far end. So you can see that is just a loosey-goosey, some kind of bending limiter. Because if it bends this much, so the gap there is about 1 millimeter. Yeah, you can see it's a lot of gap. I'm not even sure what this thing is doing. It's not really a bearing. It's just a bending limiter. So we got 4 teeth here, and then on this one we have a plurality of teeth, probably 40, 50 teeth. And so you're going to get a contact ratio between the gears. So when the gears are meshing, sometimes you have 2 pairs or 1 pair in contact. Sometimes you have 2 pair in contact. And as the gear rotates, you know, for 50% of the time you have 2 pairs in a contact. For 50% of the time you have 1 pair in a contact, you know, just from the mesh. So what the results to is that the contact ratio of the mesh is going to be around 1.5. You typically want to have something around 2, you know. For starter motors it's 0.6, 0.7, so it's really low. So let's see what else we have here. So we've got the armature. So there's the armature. It's nice and toasty. I just drilled a hole with it and it's still warm. We got a radial fan, and you can see it doesn't even have a shroud on the outside. So when we put a shroud on the outside, that will stiffen up the blades. So when this armature is spinning, it's going to create a low pressure zone in this area, so it's going to induce an axial airflow. So the air is going to start flowing from the commutator end through the motor, and then it's being tossed out through these slots here. So the fan is tossing the air out, and so it is recirculating, you know, the air, but at the end of the day it's cooling the motor. So this is lukewarm and that is lukewarm, and then the commutator is cool. So these are the balancing cuts. You can see there's a slot here, there's another one. These are typically being balanced in 2 planes, so you have 1 plane here for this bearing and 1 plane for that bearing. And in the production, this is like a completely automated process. There's not much margin on these components. On the commutator side, we have an interesting bearing. So one side has a shield, a metallic shield, and the other side has a rubber seal. I'm guessing same on this side here. So you can see it's got a rubber seal on this side. The pinion doesn't look worn, although it was probably grinding on that teeth, and you can see it grounded flat. So that's basically the failure mode. As far as the guts go here, we have a stator. There's a thermistor here, so it is most likely measuring the temperature, and it's giving a feedback to the switch here. I think this might be a Clixton switch, so if this is overheated, you know, for whatever reason, if it's overheated, then this goes open and then the motor's not going to turn on anymore. The brushes look good. The brush holders look to be brass, so that's good. It's not plastic, although it's embedded in plastic, you know, for safekeeping. But that's pretty much it. The switch is big and beefy, and it's got, you know, a lot of spring force. It's not clicking, it's just in and out, and I think there's a potentiometer inside. And then we have the FBI tracker here embedded for Home Depot's fancy. So that is just to prevent stealing from the store. But that's pretty much it. Dewalt DWD110 gear, OEM $16.71, power tool replacement. There's one for $8.69 on e-replacement parts. And obviously, you know, Google wants to sell you everything. So yeah, some of these gears are not a match, but these are definitely the match. $8.69 plus probably $10 for shipping. If you find something on Amazon, it's worth buying, especially if you have Prime shipping with Amazon. Well, at this point, she's going back together as it is. As far as fame goes, she's been in a shrine on the altar in her entire beauty, but I'm not planning to fix it. Maybe if my trusty Harbor Freight corded drill gives up its soul, I might go and fix this one. But the Harbor Freight's been working for the last 15 years, so, and I'm not using it at all. So not much hope for this one. Well, anyways, hope you guys enjoyed the video and learned something. Signing out from the shrine. See you next time. Bye. Jacob's chuck. Sure. That's just a plastic note here. And that's supposed to be Jacob's. That is a real Jacob's chuck. That is a disgrace. Ridiculous.